On number 2, the problem says that from a point 100 feet from the base of this monument, the angle of elevation is 34 degrees, 13 minutes, and 12 seconds. So then we want to draw the triangle that this situation describes. So grab a straight edge here. And the vertical lines in your pictures are going to come from the building, the house, the tree, the monument, the tower, whatever height we're trying to measure. And then the horizontal will be the ground, or the ocean surface, or the pond surface, or whatever. And then you want to close the triangle once you've marked those two. And we're told that we are 100 feet from the monument, so we want to label the base of our triangle with that. We're going to put a theta here because since we recorded the information in our workspace defining the angle that was given as theta, we can just write it as theta until we're ready to close out the problem. And then we'll come back in and write the actual measurement. And then we'll put M over here for monument. So from this angle, M is opposite me, and 100 feet is adjacent to me. So that means that we will be using the tangent of our angle to set up our equation. So we put M, try that again, M over 100, and then M equals, when we multiply both sides by 100, 100 times the tangent of the angle. Let's see if I can get the tangent there with the rest of it. And then we're going to go ahead and write the angle measure because this is actually our exact form of our answer, so we want to have it all explicitly stated. So that's 34 degrees, 13 minutes, 12 seconds. So the step we just wrote is our exact form, and you always want to write answers this way. You want to give the exact form and then convert it into the decimal form. And if you type that in your calculator after converting it to a decimal, or you could type it with the conversion in the middle of it, you should get approximately 68.01 feet. Now, I did this one because this is a very basic one triangle problem. And then for the second example, I've chosen one that involves two triangles. So just to kind of get you thinking in the broad range of problem types that you might have in trig. Okay, number 16 is about a traveling car, and it says from the top of a 100-foot building, a man observes a car moving towards him. And they draw this picture for you, so I'm going to go ahead and put the picture in a scaled down, simplified version here. Here's the building. Here's the ground, the road, and we're going to close that triangle. Well, actually, that's not really our triangle. I'm going to change that. Then there's a horizontal, which let's see if I have a dashed line here. I don't think I do in this particular thing. But basically what we would have is from this horizontal reference here, we're going to draw the triangles that we're actually going to use. So from the horizontal, I'm going to form a triangle to the first time that he sees the car, which we're going to put right about here if I can. It doesn't want to make it vertical because it wants to stick to that last green mark I made. So there's my first triangle. So that triangle is for the first time he sees the car. And it says that if the angle of depression of the car changes from 15 degrees, so we're going to call this one 15 degrees, to 33 degrees during the time he's observing it. Now let's put in our second triangle that's implied by the situation, and it's going to go right on top of the last one. But now the car is closer to him. So here's the second triangle. Not very well drawn to scale, but you get the idea here that now this angle inside the orange triangle is 33 degrees. Well, he's on top of a 100-foot building. Apparently I like problems with 100 in them today. Maybe there's something to that. All right, so he's on top of a 100-foot building, so that means that each of these triangles also has that measurement on their vertical leg. So there's the picture. So in essence, we're going to set up equations for each of these relative to our angles. So since that is where we're going, let's look at the yellow triangle first. Because if we, in fact, let's go back to the picture. I'm going to label, and I'm going to try to write in the color to match the triangle. We're going to call this x sub 2, because that will be the length of that leg. And then we're going to go back to yellow and label the yellow measurement x sub 1 to correspond to when he first saw the car. And then we're going to write equations for each of those. So I'll write both equations in the same color just because it's easier to see on the white. So for the yellow triangle, from the 15-degree angle, I know that I know my opposite, which is 100, and my adjacent is what I'm trying to find, which is x sub 1. And since that's opposite over adjacent, that tells me that we're going to be working with tangent. So I can then solve for x sub 1, use your properties of proportions that you should have seen in geometry, and that would give us 100 over the tangent of 15 degrees. So I know that my first distance is going to come from that. Then I'm going to do the same thing for the second triangle, and I get, again, it's tangent because it's the same relationships in the triangles, but now it's 33 degrees that we're working from, equals, and my opposite is still a 100, and now my adjacent is x sub 2. Well, the distance traveled is the difference between the two, so I need to isolate x sub 2 here, which is 100 divided by the tangent of 33 degrees. So then the distance traveled is going to come from x sub 2 minus x sub 1, which is equal to 100 over the tangent of 15 degrees minus 100 over the tangent of 33 degrees. And then that's the exact form of our answer. So then we can approximate that to be, if I have the answer handy, it's 219 feet approximately. So if you wanted to write the final statement that I've been trying to encourage you all semester to write to verify that you've actually answered the question, you could say, the car travels 219 feet. And that will take care of that problem, and that's the end of our example videos.